So the next way to solve systems is by using substitution. So the first thing we have to understand is, what does it mean to be equivalent, and what is an equivalent substitution? The root word of equivalent is equal. So we're looking for a substitution that is equal. So let's think about what are some equivalent substitutions for $100. We could have a $100 bill, or we could have two 50s, or we could have 5 20s, we could have 10 10s, or we could go crazy and we could have 10,000 pennies. So all of those are equivalent substitutions for $100. They are interchangeable. One of them can be put in for the other at any moment because they are all equal to each other. So that's what we're going to be considering in solving systems using substitution. So here's a system. Given the system, make a substitution and solve for the point xy. Remember, the solution to the system is where the two lines intersect on the graph. But what we saw in the application video in the last section, and also in one of the other problems, is that sometimes the graph is not always precise enough to actually determine what the solution to the system is. So that's why algebra comes in handy here. But the first thing we want to do is think about, well, what is going to be my substitution? Well, if we read y equals 2x plus 6, we see right away what y is equal to. So if y equals 2x plus 6, and in the next equation, y plus 1 equals 4, can't I make a substitution for the y? Everywhere I see y, I can plug in 2x plus 6. So let's do that. So y, which is 2x plus 6, plus 1 equals 4x. And when I make that substitution, it turns into a simple equation to solve. First of all, we need to combine like terms here. 6 plus 1 is 7, so 2x plus 7 equals 4x. And then next, subtract 2x, subtract 2x, and we end up with 7 equals 2x. Divide by 2, x equals 7 halves, which is the same as 3.5. That's something very easy for us to plug in. So x equals 3.5. So now that we know the value for x, we can use it as a substitution. So let's go back and let's take that value for x and let's plug it back in order to solve for y. So we're going to be plugging it back in here. So y equals 2 times 3.5 plus 6. So 2 times 3.5. Well, remember, 3.5 is 7 over 2. So if we have 2 times 7 over 2, the 2's just cancel. And we end up with 7 plus 6, which is 13. So we found our x and we found our y. This is the solution to the system. And then from there, let's give it a quick check. And we'll use the second equation to give it a quick check. And we're going to use substitution to check it as well. So y plus 1, so y is 13, plus 1 equals 4 times 3.5. So 13 plus 1 is 14, and 4 times 3.5 is going to be the same as 4 times 3, which is 12, plus half of 4, which is 2, and 14 equals 14. So it checks. So this is our solution to our system using substitution. Let's do it again. Now we've got x equals 3y plus 2. So right away, we know what x is equal to. We can take this equivalent substitution for x and plug it in to the second equation. Let's do that. So 3y plus 2 minus 5y equals 4. So let's combine like terms on the left-hand side. 3y minus 5y is negative 2y plus 2 equals 4. And then minus 2 minus 2. The 2's cancel. Negative 2y equals 2. Divide by negative 2. Y equals negative 1. Once again, just a reminder that I'm keeping my equal signs lined up and I'm working down the page, just like we have been since chapter 1. So this is what y is equal to. So now we'll use substitution again. Let's use the equation that we haven't worked with yet, which is the first one. So if y equals negative 1, we're going to plug it in right there. X equals 3 times negative 1 plus 2. X equals negative 3 plus 2. X equals negative 1. There's x, there's y, negative 1. And let's check our solution by plugging it in to the second equation. So x, remember x, y, x is negative 1 minus 5 times y, which is negative 1. Does that equal to 4? Negative 1 plus 5 does indeed equal 4. So it checks. So this is our true solution. One last problem. M equals negative 4t plus 2. T equals m plus 8. We don't have to have everything in terms of x and y. We can use other variables and we'll just put our answer in alphabetical order. So we're looking for m t. Well, we know that t is equal to m plus 8. So we can plug it in right there. So m equals negative 4 times m plus 8 plus 2. So distribute the negative 4, so m equals negative 4m minus 32 plus 2. Combine the like terms, so m equals negative 4m minus 30, keeping my equal signs lined up. So now we've combined like terms here. Let's move this 4m over, plus 4m, plus 4m. 5m equals negative 30. Divide by 5, divide by 5. I'll move to the right since I'm running out of room. M equals negative 6. So there's our m. Let's plug it in and let's solve for t. So t equals m, which is negative 6, plus 8. T equals 2. So there's m, there's 2. Put it in over here in my check box. Let's check it out. So if m equals negative 6 and t equals 2, let's plug it back into the first one. Is negative 6 equal to negative 4 times 2 plus 2? Negative 6 equals negative 8 plus 2. Negative 6 equals negative 6. It checks. That is solving systems by substitution, which I think is almost always the easiest way to solve a system.